Given this equation, 3 multiplied by x raised to the power of logarithm of 3 equals 4 multiplied by x raised to the power of logarithm of 4, then our goal is to find the real value of x that satisfies this equation. Now, pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Given this equation, 3 multiplied by x raised to the power of logarithm of 3 equals 4 times x raised to the power of logarithm of 4, the goal is, of course, to find the value of x. Now, take note, this logarithm of 3, this exponent, is just for x only, not in 3x. Because if this logarithm of 3 is an exponent of 3x, we need to have a parenthesis like this. Alright? So this exponent, logarithm of 3, is for x only, not to 3. Alright, so now let's get this equation. And what we're going to do here is to divide both sides by 3. So this will happen if we divide both sides by 3. And now, what we're going to do is to divide both sides by x raised to the power of logarithm of 4. Now, let's focus on this result. And what we're going to do is to focus on the left-hand side of our equation. Because we have the same base, so what we're going to do is to use some loss of exponent. If we have b raised to the power of a over b raised to the power of c, we can rewrite this as b raised to the power of a minus c. So the left-hand side of our equation can be written as x raised to the power of logarithm of 3 minus logarithm of 4. Now from here, notice we can rewrite this using a single logarithm. Because take note, when we have logarithm of a minus logarithm of b, we can rewrite this as logarithm of a over b. So the exponent of x can be written as logarithm of 3 over 4. Now let's focus on this result. And finally, to solve for the value of x, let's take the logarithm of both sides. Now, one property of logarithm is when we have here an exponent, we can put this exponent before the logarithm. So if we have logarithm of b raised to the power of a, we can rewrite this as a multiplied by logarithm of b. So the left-hand side of our equation, we can rewrite this as logarithm of 3 over 4, which is the exponent of x, times logarithm of x equals logarithm of 4 over 3. Now, notice, take a look at this one. This is 3 over 4, and on this part, this is 4 over 3, which is reciprocal of each other. Now, what we're going to do is to take the reciprocal of this, and when we do that, we get a negative exponent. So, this is simply equivalent to 3 over 4 raised to the power of negative 1. Now, from here, we can now use again this identity. And we can put this negative 1 before the logarithm. So this can be written, the right-hand side, as negative 1 times logarithm of 3 over 4. And the rest is just bring down. And now, what we're going to do is to divide both sides by logarithm of 3 over 4. This is just equal to 1. Alright? Therefore, the resulting equation is just logarithm of x equals negative 1. And we can rewrite this logarithmic equation into an exponential equation. Take note, when we don't see any base, the base is just 10. Therefore, we can say that x equals 10 raised to the power of negative 1. And of course, we want positive exponent. So let's take the reciprocal of 10 raised to the power of negative 1. We get that x equals 1 over 10. Therefore, in this equation, x equals 10 is the value of x that satisfies this equation. And of course, we need to check that if we replace all x with 1 over 10, the left-hand side and the right-hand side balance. And here's our checking. You can pause this video right now and see the checking. And as you can see, we get, at the end, we have 1 on the left side and 1 on the right-hand side. So they are balanced. Therefore, x equals 1 over 10 is technically a solution to this equation. Therefore, given this equation, 3 multiplied by x raised to the power of logarithm of 3 equals 4 times x raised to the power of logarithm of 4, then the value of x that satisfies this equation simply equal to 1 over 10. And as always, we are Done.